Okay, so good morning, everyone. So our topic for today is about implementing the model-driven architecture. So there has been a long history of research on the use of transformations to carry out design and program refinement. Grice used transformation to map specification into programs that establish the specification. So extensive strategies and tool support for design refinement by transformation were developed in 1980s and 1990s, leading to systems such as KIDS. No? And this topic described the concept of terminology of the model-driven architecture, or the MDA, and the rule of transformation and refactoring. So it is shown how transformation can be formally represented and justified in a survey of current MDA or model-driven architecture tools. No? So a computations independent model, or the CIM, abstract completely from implementation details and uses terminology familiar to practitioners in the domain of the application. And it is similar to the concept of domain model that and can be used to assist in establishing requirement and expressing this in details. So it describes the system in terms of the domain in which it must operate. So the transformation on models are fundamental to the model driven architecture approach. So either as a means to improve a model or to make it more generic and flexible for use as platform independent model, or PIM. So or as means to transform PIMs into platform specific model of the PSMs. No? So for reverse engineering or round trip engineering, PSM to IPM transformations, essentially ways by of abstracting away from model specific details are also important. And this topic also describes a number of useful transformation and gives a framework for formally representing and reasoning transformation. So to give us more details about the topic, let us all welcome Ms. Shirley Barcoma. Go ahead, ma'am.
Thank you po. Hi, good morning to each and everyone. My name is Shirley Barcoma. My topic is all about implementing the model-driven architecture. I will be explaining the MD approach in terms of major concepts, the premises, and the goals which is drive its adoption. The Object Management Group was formed as a standard organization to help reduce complexity, lower costs, and hasten the introduction of new software application. One of the major initiatives through which the OMG is accomplishing this goal is by promotion of model-driven architecture. As an architectural framework for software development, this framework is built around the number of detailed OMG specifications, which are widely used by the development community. In 2001, the OMG adopted the model-driven architecture as an approach for using models in software development. Its three primary goals are portability, interoperability, and reusability through architectural separations of concerns. One fundamental aspect of MDA is its ability to address the complete development life cycle, covering analysis and design, programming, testing, component assembly, as well as development and maintenance. MDA itself is not a new OMG specification, but rather an approach to software development which is enabled by existing OMG specification, such as Unified Modeling Language, the Meta Object Facility, and the Common Warehouse Meta Model. Other adopted technologies which are of interest are the UML profile for enterprise distributed object computing, including its mapping to EJB and the COBRA component models. With new platforms and technologies constantly emerging, MDA enables the rapid development of new specifications that leverage them and streamlines the process of their integration. In this way, MDA provides a comprehensive structured solution for application, interoperability, and portability into the future. Precise modeling of the solution domain in UML provides the added advantage of capturing inherent intellectual property in a technology-neutral way. As an illustrated in the diagram, the OMD envisions MDA to encompass a full range of pervasive services, which are commonly found in modern distributed application. So ayan po yung kanyang major MDA concept. Before MDA and related concept can be explained and analyzed, a couple of basic concepts have to be defined. One here is the system itself. We have to take note that the context of MDA is the software system, either pre-existing or under construction. We have two different system notions exist, the teleological and the ontological system notion. The theological system notion is about the function and the external behavior of a system. This notion can be visualized with a black box model. The theological system notion is adequate for the purpose of using or controlling a system. The ontological system notion, on the other side, can be used for building or changing a system. It is about the constructions and operation of a system and can be modeled with a white box model. Both theological and ontological system notion are relevant for designing a system. In other words, both the functions and the constructional perspective of a system are relevant. In software, the terms functional design and technical design are often used to refer to these perspectives. A model is a formal specification of the functions, structure, and behavior of a system within a given context and from a specific point of view or reference view point. A model is often represented by a combination of drawings and text, typically using a formal notation such as Unified Modeling Language or UML, augmented where appropriate with natural language expressions. A specific is said to be formal when it's based on the language that has a well-defined semantic meaning associated with each of its constructs. To distinguish, it's a form simple diagram showing boxes and lines. It is formalism, which allows the model to be expressed in a format such as XML in accordance with the well-defined schema. So to emphasize, a model of a system is a description or specification of the system and its environment for some certain purpose. A model is often represented as a combination of drawing and text. The text may be in a modeling language or in a natural language. Describe an approach to software development whereby models are used as the primary source of documenting, analyzing, designing, constructing, developing, and maintaining a system. The architecture of a system is a specification of the parts and connectors of the system and the rules for the interactions of the part using the connectors. Within the context of MDA, these parts, connectors, and rules are expressed via a set of interrelated models. A viewpoint on a system is a technique for abstraction using a selected set of architectural concepts and structuring rules. In order to focus on a particular concern within that system, here abstraction is used to mean the process of suppressing selected detail to establish a simplified model. MDS specification 3 defaults view on a system: computation independent, platform independent, and a platform specific. The computation independent viewpoints focuses on the context and requirements of the system without consideration for its structure or processing. It focuses on the environment of the system. and the requirements for the system. The detail of structure and processing of the system are hidden or as yet undetermined. The computation is independent viewpoint can be compared to theological system notion. The platform-independent view focuses on the operation of a system while hiding the details necessary for a particular platform. A platform-independent view shows that part of the complete specification that does not change from one platform to another. A platform-independent view may use a general purpose modeling language or a language specific to the area in which the system will be used. OMG 2003. The platform-independent viewpoint can be compared to ontological system notion. The ontology is implementation independent by definition. A platform-specific viewpoint augments a platform-independent viewpoint with the details relating to the use of a specific platform. It combines the platform-independent view with additional focuses on the detail of the use of a specific platform by a system. A platform is a set of subsystems and technologies that provide a coherent set of functionality through interfaces and specified usage patterns, which any application supported by that platform can use without concern for the details of how the functionality provided by platform is implemented. In principle, a platform is a place to launch software on. Example of platforms are operation system, the Java virtual machine, runtime libraries of programming languages, databases, user interfaces, and middle solutions, etc. Platform independence is a quality, which is a model may exhibit. This is the quality that model is independent of the features of the platform of any particular type. Like most, qualities platform independence is a matter of degree. So, one model might only assume availability of a features of a very general type of platform, such as remote invocation, while another model might assume the ability of a particular set of tools for the Cobra platform. Likewise, one model might assume the availability of one feature of a particular type of platform, while another model might be fully committed to the type of platform OMG 2003. Platform model describes a set of technical concepts representing its constituent elements and the services it provides. It also specifies constraints on the use of these elements and services by other parts of the system. Model transformation is the process of converting one model to another within the same system. The transformational combines the platform independent model with additional information to produce a platform specific model. An implementation is a specific that provides all the information required to construct a system and to put it into operation. It must provide all of the information needed to create an object and to allow the object to participate in providing an appropriate set of services as a part of the system. MDS specified three default models of a system corresponding to the three MDA viewpoints defined as a while ago. The MDA models include computation independent model, platform independent model, platform, specific model. These models can perhaps more accurately be described as layers of abstraction, since within each of these three layers, a set of models can be constructed, each one corresponding to a more focused viewpoint of the system, user interface, information, engineering, architecture, etc. Computation independent model. It also often referred to as a business or domain model because it uses a vocabulary that is familiar to the subject matter's expert. It represents exact what the system is expected to do, but hides all information technology related specification to remain independent of how that system will be or currently is implemented. The CIM plays an important role in bridging the gap which typically exists between this domain expert and the information technologies responsible for implementing the system. In MDA specification, the CIM requirements should be traceable to the PIM and PSM construct that implement them and vice versa. A computation-independent model is a view of a system from the computation-independent viewpoint. The CIM does not show details of the structure of the system. A CIM is sometimes called a domain, model, and vocabulary that is familiar to practitioners or the domain in question is used on its specification, OMG 2003. It is assumed that the primary user of the CIM is the domain practitioner or business consultant. The user of CIM doesn't have to have knowledge about the models or artifacts used to realize the constructions of its application complying the requirements defined in CIM. The CIM specifies the function or external behavior of a system without showing constructional details. The CIM plays an important role in bridging the gap between domain expert or business expert and expert of the design construction of the system or IT experts. Platform independent model exhibit a sufficient degree of independence so as to enable its mapping to one or more platforms. This is commonly achieved by defining a set of services in a way that abstract out technical details. Other models then specify a realization of these services in a platform-specific manner. A platform-independent model is a view system from the platform, independent viewpoint. A PIM exhibit a specified degree of platform independence so as to be suitable for use with a number of different platforms of similar type OMG 2003. A PIM described the construction of a system on ontological level, meaning that the construction of a system is specified without implementation details. The ontological model of system is defined as something is a system and only if it has the next properties. Composition, a set of elements of some category. Physical, biological, social, chemical, etc. Environment, a set of elements of the same category. The composition and the environment are disjoint. Production, elements in the composition produce things, products, or services that are delivered to the elements in the environment. Structure, a set of interaction bonds among the elements in the composition and between these, the elements in the environment. An important characteristic is the category to which the element of system belong: physical, biological, social, chemical, etc. In the case of MDA, we start with the model of an enterprise. By model translation, it is tried to convert this model into a model of software system. An important characteristic is the category to which the elements of system belong to. By model translation, it's tried to convert this model into a model of a software system. Platform-specific model combines the specification in the PIM with the details required to stipulate how system uses a particular type of platform. If the PSM does not include all of the details necessary to produce an implementation of the platform, it is considered abstract, meaning it relies on the other explicit or implicit models, which do not contain the necessary details. A platform-specific model is a view of system from the platform-specific viewpoints. A PSM combines the specification in the PIM with the details that specify how the system uses a particular type of platform. OMG 2003. In other words, the PSM is a more detailed version of a PIM. Platform-specific elements are added. When defining a PSM, a target platform model has to be available. A platform model provides a set of technical concepts representing the different kinds of parts that make up a platform and the services provided by the platform. It also provides for use in a platform-specific model, representing the different kinds of elements to be used in specifying the use of a platform by an application. MDA has been profitably implemented in the many small and large organizations. While some companies prefer to keep their success as secret to their competition, many have agreed to publish their accomplishment, as can be seen on the OMG's website, as well as the various magazine articles. The promises of model-driven architecture is to facilitate the creation of machine-readable models with the goal of long-term flexibility in terms of technology obsolescence. New implementation infrastructure can be more easily integrated and supported by the existing designs. Portability. Existing functionality can be more rapidly migrated into new environments and platforms as dictated by the business needs. Productivity and time to market. By automating many tedious development tasks, architects and developers are freed up to focus their attention on the core logic of the system. Quality. The formal separation of concern implied by this approach, plus the consistency and reliability of the artifacts produced all contribute to the enhanced quality of overall system. Integration. The product of integration bridges with legacy and/or external system is greatly facilitated. Maintenance. The ability of the design in a machine readable from gives analysts, developers, and testers direct access to specification of the system, simplifying their maintenance chores. Testing and simulation. Models can be directly validated against requirements, as well as tested against various infrastructures. They can also be used to stimulate the behavior of the system under design. When it comes to the model-driven process, whatever the ultimate target platform may be, the first step when constructing an MDA-based application is to create a platform-independent model expressed via UML. This general model can be transformed into one or more specific platforms such as CCM, AJB, NET, SOAP, etc. Applying a consistent architectural style across viewpoints of the system is one illustration of such as horizontal transformation. Other example include, within CIM, create a target model containing all of the business rules defined in the core business model. With an PSM, create a target JUnit test model from a Java class model. So the MDA process. Also, the PSM and one layer of abstraction may take on the role of PIM with regards to the further transformation down into another layer. Beyond the perhaps simplistic notion of CIM, PIM, PSM, The two key concepts of MDA are models and transformations. The general patterns is the source plus transformation. Transformation rules is equal to target model. So source model plus transformation rules equals target model. These patterns can be repeatedly applied to the successive models, each one playing the role of either a PIM or PSM. So the first part of MDA is a transformational mapping. MDA mapping provides specification for how to transform a PIM into a particular PSM. The target platform model determines the nature of the mapping, while part of the transformation can result from a manual exercise. The intent is clearly to automate as much of the process as allowed by the toolset in use. Let's take the example of mapping which defines annotation, called markers in MDA parlance, that are to be used for guiding the transformation of UML PIM to an EJB PSM. Marking a UML class with a stereotype session would result in the creation of session bin and other supporting classes within the PSM. Transformation rules between models can be expressed at the type level from the types specified in the PIM language to type expressed using PSM language. In UML, example of such types referred to here include class, attribute, and operation. In accordance to patterns of type usage in the PIM, example, GOF, strategy pattern with the PIM can translate in the idiomatic equivalent in the PSM. At the model, at the meta model level, transformation that need to bridge model languages. The second process is marking models. Generally, type marking are insufficient to specify a complete transformation. Additional rules are required to specify that certain types in the PIN must be annotated, marked a specific way in order to produce the desired output in the PSM. This extra information cannot be determined from the PIM itself. A marker represents a concept in the PSM, which is applied to an element of the PIM in order to indicate how the element is to be transformed. Marks being flatworm specifier are considered part of the PSM. In a multiple PSM scenario, each PSM would use different marks against the same PIM. The PIM plus all of the platform marks constitutes the input to transform process resulting in PSM. Implicit or explicit transformation rules exist to indicate which model elements in PIM are suitable for certain marks in order to generate the desired element in the PSM. In a set of marks can be viewed as an overlay or transparency placed over the PIM for the purpose of the transformation. This set can optionally be supplied as part of the UML profile. Another option is to associate a set of marks with a template containing the rules according which instances in a model are to be transformed. These rules can be specified which values in the source model can be used to fill the parameters of the template. Third is mapping languages. A model transform mapping must be specified using some languages. It natural language, an action language, or a dedicated mapping language. The OMG is currently in the process of adopting the MOF Query View Transformational specification as a portable mapping language. Fourth, MDA process is the recording of transformation. A record of transformation should include a chart indicating which PIM elements were mapped to which PSM elements and include the mapping rules used for each part of the transformation. Fifth, MDA process is the illustration of transformation. The uses the diagram uses UML notation to present the various concepts involved in MDA. For given platform, example, target model, it distinguishes between the abstract view of the platforms, transformation directives, and a concrete implementation in the context of a specific source model to be transformed into this platform. So ayan po, the MDA process. Next po. A further way to organize transformation mapping is via an inheritance hierarchy. For example, ayan po, RDBMS. Information model could be specialized for specific database vendor. So mayroon tayo dito yung under ng RDBMS mapping, nasa baba niya pa yung Oracle mapping and SQL Server mapping. The sixth MDA process is the generation of code and other artifacts. So the final step is the transformation process to generate the implementation code as well as perhaps other kinds of supporting artifacts such as configuration files, component description files, deployment files, build scripts, etc. The more fully the application semantic and runtime behavior can be included in the PSM, and more complete the generated artifacts can be. Depending on the maturity and quality of MDA toolset, code generation varies from significant to substantial or, in some cases, even complete. Note that even minimal automation simplifies development work and represent a significant gain because of the use of consistent architecture for managing the platform independent and platform specific aspect of the application. After the final MDA process, which the generation of codes and other artifacts is to move forward, go ahead with the next steps. One is think of the transition process. Moving from traditional software development approach to one that is model-driven is a full-fledged transition program that requires formal planning, orchestrations, and sponsorship. Transitioning an organization to the model-driven approach is a major project program that will take time and resources to plan and manage over a period of years. Defining the transition life cycle consists of developing a strategy and a plan for each stage and monitoring the result activities. This requires a major ongoing effort and continuing support from IT management. The transition is not a one-time process improvement effort, rather it's a transition program that must be formally planned, approved, and founded by management. It must be executed with the all diligence and check marks of a real project. Moving too fast, out of sequence, or proceeding without proper planning simply puts the whole transition process at risk. The main ingredients for ensured success is keeping the vision of the transition in sight. Second thing is to promote tooling. Tooling is an essential part of MDA environment because tool capabilities replace human skill sets. Understanding that the tools will generate most of your project artifacts, it is crucial to establish the right infrastructure for the development environment, along with a dedicated team and support it, manage it, and continually evolve it to meet the IT development requirements. The IT organization must carefully evaluate the select and right tools with the capabilities to meet the organization's specific requirements. The companion tool specific MDA papers offers guidance and features checklist to consider. So next step po, the third is all about considering the factors of success. establish the foundation, the equivalent to investing the time and forethought in the analysis piece of the transition project. The foundation is manifested as set of blueprints for your transition and measurement system to track progress. Setting the appropriate expectation is crucial, especially when it comes to keeping early expectation in bounds with the current realities of the daily workload. Designing the development environment properly for that model-driven approach is one of the most crucial factors for success. This is where tooling takes over human grunt work and transformation replaces routine skill sets. Plan for pilot projects and don't be tempted to jump into a real project only equipped by the notions of how to proceed the new approach. Try before you buy. A successful pilot can also be turned into a real deliverable. Plan for recurrent review and adjust milestone. This is where you put measurement system to work. With no proof of progress, you cannot sustain funding. So, yan po yung akin reference. Yan ko po kinuha. Thank you.
Okay, so to add on now with the discussions of about the implementing the model-driven architecture, no? So a while ago, our presenter mentioned about refactoring. So it is the parameterized behavior-preserving program transformation that modifies the design in source code of an application. When we say reverse engineering, it is the technique of extracting a design or a specification from a system implementation. It's required if a company wants to capture business rules that may be embedded in the legacy program. The reverse engineering followed by a standard forward engineering, PIM, to PSM transformation. And this is how an application is moved from one platform to another. On the other hand, no, a virtual machine is a collection of operation or services that are platform agnostic and may be deployed on a variety of platforms, because the virtual machine may already have an implementation on the target platform. Defining a PIM in terms of virtual machine might reduce the amount of effort required to implement the PIM. An application can be thought of a hierarchy of layers, with each layer relying solely on the interface and the specification of each supplier's layer or supplier layers rather than implementation. And this means that the application of PIM to PSM mapping can theoretically be separated into separate mappings for each layers, with the layers interfaces preserved by the mappings. So the language transformation using extensible style sheets, yung XSLT, no? The extensible style sheet language transformation is an XML notation for converting one XML document or the source document to another, the destination document. It's most commonly used to mark up an XML document into XHTML, no, documents, no? Page for browser rendering, but it may also be used to change data from XML documents that represent UML diagrams from PIM into XML for equivalent PSM diagrams. The Java metadata interface, no, which provide Java interfaces to access and edit meta models, including the UML 2.0 meta model, is another transformation method, because a UML model to be changed is stored in XMI format and utilized to populate a UML meta model repository using this method. So in order to implement a transformation, GMI methods are utilized to query and update this repository. So the work at the same level as the REI technique. So as a result, it is superior than a text-based technique like XSLT. So it does, however, necessitate Java knowledge. Another thing is the use of transformation to carry out design and program refinements has a long history of research. Okay, Grice used transformation to translate specification as post-condition into programs that define the specification. So again, as I mentioned, extensive methodologies and tool support for design refinement via transformation were developed, resulting to system like KIDS. No, much of the current work on the MDA is focused on transformations. No, a thorough proposal for transformations rather, queries and views of the next OMG MOP 2.0 or the QVT standard. Okay, so again, as I mentioned earlier, a computation independent model or the CIM abstract from implementation specify in employees vocabulary common to practitioners in the application domain. Akin, it's to the notion of a domain model, and it can be used to help define and articulate requirements in detail. It gives a description of the system in terms of the domain in which it must functions. The DMA technique relies heavily on the model transformation, either to improve a model and make it more generic and adaptable for usage of a platform-independent model, or to change PIMs into platform-specific models or the PSM. Again, PSM to PIM transformation, which are simply means of abstracting away from model specification information, are also crucial for reverse engineering or round-trip engineering. And this also provide a framework for formally describing and reasoning transformation, as well as the list of useful transformations. So I think that's it for this topic.